Hello everyone, welcome back to our channel. Today we are back with one more tree problem. That is, the name of the problem is validate binary search tree. And this is also a problem I have taken from Leetcode blind 75 SD sheet. And the problem statement is basically we are given the root of a binary tree and we need to determine if it is a valid binary search tree. So for your all information, like a valid binary search tree follows specific rules. Okay. So these rules are basically left subtree contains values less than the current node. That is, I will tell you an example. Let's just see the rules. Left subtree contains values less than the current node. Okay. Right subtree contains values greater than the current node. Okay. And both left and right subtrees must also be the binary search trees, right? So what it is saying, basically 2 is the current node. If we say root node, then at the left of it, if the value of a left subtree is less than the value of the current node, that is 2 is greater than 1, then it is following the condition of binary search tree. And the right subtree, the value should be greater than 2. So 3 is greater than 2. Here we can say that this is following the condition of binary search tree. Similarly, in example 2, if we see 5 is the root node and at the left of it 1 is there, so 1 is less than 5, so it is following here. But here also we can say that 4 is also less than 5, so we can say that 4 should, here the value which satisfies the binary search tree condition is basically should be the at least greater than 5. In order to make this valid binary search tree, it should be at least greater than 5, so that the right subtree must be greater than left subtree. Okay. So after here the output is false. I will come to that part. Like input root was 213 and output was true because here the condition was true. And in example 2, as we saw here, as I told you, 4 is less than 5, but there should be for making the possible, like it should be following the binary search tree condition. It should be minimum. Here the value should be minimum, like it should be greater than 5, then only we can check for other subtrees. Okay, so we have taken this as a false, right? So what I'm trying to say is basically how to validate binary search tree in this question. So brute force is quite simple. You all can think of an approach like in order traversal and checking. The idea is basically we perform an in order traversal. If I say in order traversal, that means left, root, right? And we have to store the elements in array. If the array is sorted in strictly increasing order, then it is a valid BST. Otherwise, it is not, because we can see 1, 2, 3. It is following true. If we see 1, 5, 4, but here we saw 5 is greater than 4, then it is not a valid binary search tree. It is a very simple approach to understand the question, like strictly increasing or strictly decreasing. So the complexity analysis for this approach is basically O of n, and in order traversal visits each node once. So time complexity will be O of n. Okay, and the space complexity will also be O of n. That is extra space for storing the in order traversal. Okay, but if we want to improve the time and space complexity, we have to think something better solution, maybe recursion, maybe some better traversal techniques. Okay, so let's have a quick view on optimal approach, basically using recursion and valid range checking. Idea is, instead of storing values in an array, we will check each node in place, right? Each node should lie in a valid range, minimum and maximum. And we will consider it as like a left child and right child. Left child should be in range minimum, comma root value, and right child should be in range root value and max. Recursively, we have to check for left and right subtrees, okay? And we have to dry run it with an example. For input 514 null 36, okay? We have to start with validate like root is equals to 5, then min should be like minus infinity and max should be plus infinity. Left subtree, if we want to validate, then 1 comma minimum is equals to minus infinity and maximum is equals to 5. Then this condition is valid, okay? So we have to like check for right subtree. We have to validate 4 comma minimum is equals to 5, max is equals to infinity. Here we can strict this, no, we can see it clearly. 4 is less than 5, so 4 is not greater than 5, but we were expecting a value which should be greater than 5 in order to make it a binary valid binary search tree. So it is not there, so we will straight away return false. If we see the complexity analysis, time complexity will still be remain same O of n, as each node is visited only once. Okay, but space complexity will get reduced, basically O of h, because we are taking like recursive call stack, and h is equals to log n for balanced tree, and at the worst case if the tree is skewed, then it will be O of n. Okay, I hope you all get the approach what I'm trying to deliver right now in the video. Let's see in the code what I have done. Basically, this was the function given on Leetcode. Base case we have to write. Whenever we write a recursive function, we need to have like base case in order to start with. Okay, so base case is generally in tree questions. If we have to see, we can see very like in mostly every question, this is the base case. If not equal to root, we have to return true. Okay, that is an empty tree is a valid binary search tree. Now we have to check if the current node's value violates the binary search tree property. Like if the root value is less than equal to minimum value, or root value is greater than maximum value, we have to return false. Okay. After that, we have to recursively check left and right subtrees with updated valid range. Okay. We have to return validate root left minimum value root value. That is left subtree. Values must be less than root value. Okay, and validate root right root value max value. Okay, right subtree, basically value must be greater than root value. Okay, now we have a function like bool is valid BST. We have to call the helper function with the initial range minus infinity comma plus infinity. We have to return it right away, like return validate root long min and long max. In this way we can get to our desired solution for checking the whether the tree is a binary search tree or just a normal tree. So I hope I was able to explain you guys the solution in a better manner. If you understood the solution, please hit the like button and also subscribe to the channel, and till then, thank you.